All right, let's dive in. In this explainer, we're going to take our Spring Boot application all the way from just being code on our machine to a live, testable API endpoint that you can actually interact with. Let's get to it.
Welcome back to part 2. So in part 1, we got our Spring Boot foundation and data layer all set up, creating our user entity and the user repository. Today, we're going to build the final layers on top of that and expose that data to the world.
Okay, here's our build plan for today. We'll kick things off with the service layer, which is where our business logic will live. Then, we'll build the controller layer to handle the API endpoints. After that, we'll get our database and configuration sorted. And finally, the fun part. We'll run the whole application and prove it works with a couple of simple crawl commands. First up, let's tackle the service layer. You can really think of this as the brain of our application. It's where all the core logic and decision-making will happen, keeping it nicely separated from everything else.
Okay, let's break down this user service code. That @service annotation at the top, that's just us telling Spring, hey, this is a business component, please manage it for me. Then you see @autowired. This is pure magic. It's Spring's dependency injection doing its thing, automatically giving us an instance of our user repository from part 1. We don't have to create it ourselves. This makes our create user and get user methods super clean. They just use the repository to talk to the database.
So you might be wondering, why even have this layer? Well, it's absolutely crucial for good design. It wraps up all our business rules and acts as a bridge between the web-facing controller and the database-facing repository. This is a core principle called separation of concerns. It keeps our controller's job simple, just handle HTTP traffic, and it makes our business logic way easier to test all by itself. All right, with the app's brain in place, let's build its public-facing door. We're moving on to the controller layer. This is the part of our application that listens for incoming requests from the internet and decides what to do with them.
This piece of code really shows off how straightforward Spring makes building REST APIs. The @REST controller annotation tells Spring this class is all about handling web requests. Then, @requestmapping/API/users sets the base URL for every method inside this class. From there, we define our specific endpoints. @postmapping handles HTTP post requests to create a new user, and it gets the data from the @request body. Then, @getMapping/ID handles GET requests, using an @path variable to snatch the ID right out of the URL. It's so clean.
So to quickly recap, we've just created 2 RESTful API endpoints. A POST request to API users is going to create a new user for us, and a GET request to API users followed by a specific ID will retrieve that one user's data. Simple as that.
We are so close to running this thing. But before we can, we need to handle the final bit of setup, getting our in-memory H2 database configured and telling Spring exactly how to boot everything up.
Now, this slide shows off a really powerful Spring feature called profiles. On the left, you see the file is named applicationdev.properties. This file holds settings that are specific to our development environment. Now look at the run configuration on the right. That little VM option, -d spring.profiles.active=dev, is the key. It explicitly tells Spring, when you start, I want you to use the dev profile. This is how you manage different settings for development, testing, and production without ever changing a line of your code. It's a lifesaver.
Let's quickly peek inside that properties file. First, we're telling Spring to use an in-memory H2 database. This is perfect for development because it requires 0 setup and gets wiped clean every time we restart. Second, ddl-auto=update tells Hibernate to automatically create our database tables based on our user entity. So convenient. And finally, we enable the H2 console, which is this awesome web-based tool that lets us peek inside the database while the app is running. It is incredibly useful for debugging.
All right, the setup is complete. The code is written. It is time for the moment of truth. Let's fire up our Spring application and verify that our endpoints are actually working.
We're going to use a simple command line tool called curl to send a post request. As you can see in the command, we're targeting our localhost 8080/API/users endpoint. We set the content type header to let our app know we're sending JSON, and then we provide a simple JSON payload with the name Johnny.
And success! The terminal shows us an HTTP 200 OK status, which is exactly what we wanted. It means the request was processed successfully. And even better, look at the response body. Spring has returned our new user object, complete with an ID of 1 that was automatically generated by the database. Perfect!
Now let's prove the user was actually saved in the database. We'll send another curl request,
But this time, it's a simple GET request to /API/users/1, using the ID that we just got back from our first request.
And there it is, another 200 OK status, and the JSON payload for our user, Johnny. This confirms that our entire flow is working end-to-end. The controller got the request, passed it to the service, which used the repository to save, and then retrieve the data from our H2 database. It all works.
Now, in a perfect world, that would work every single time. But let's be realistic. What happens if you run into an issue? Don't worry, it happens to everyone. Let's cover a few common troubleshooting steps.
First, check if another application is already using port 8080. That's a very common one. Then, double and triple check your code for typos, especially in your @request mapping paths. Make absolutely sure you set that -spring.profiles.active=dev VM option correctly. Otherwise, Spring won't load our database configuration at all. And finally, just make sure the JSON in your curl command is properly formatted. A single missing quote can break the whole thing. We've now successfully built and manually verified our API. But doing this by hand every time we make a change just isn't efficient. So in Part 3, we will transition to our test repository and set up Cucumber to automate this entire verification process using behavior-driven development.
For the full code snippets and the complete step-by-step guide, be sure to check the Medium article link in the video description below.